All right, welcome to Intro to Scripting. My name is Nick McSpadden. I see a lot of people were at my previous session, so hello again. For those who are new, I'm the Client Systems Manager at Schools of the Sacred Heart in San Francisco. We're a private school, 4 different private schools, about 1,000 students, 250 staff. I manage about 850 or so Macs, about 200 iPads, which is, of course, about to explode. And most of my time is spent trying to avoid using the mouse whenever possible. I really like using the keyboard because it's faster. And scripting is a great way to sort of get into finding ways to mitigate some of the horrible slowness of the Finder interface, another interface that we have to deal with. This is going to be a 500-foot overview, so we're just sort of going to focus on the beginning and working our way into the basic kind of scripting that we're going to need to accomplish most tasks that we'll want. There's plenty of resources on scripting in general on the internet. Just throw a rock at Google and you'll get a mountain slide of them. So this is really just going to be a jump-off starting point for people who are new to the idea, who aren't sure where and how to start. Why bother with scripting? Most of the things that I've written up here generally hint at really one important aspect. We really hate slow things. Clicking and moving the mouse is slow. Clicking the mouse a lot is a lot slower. When you need to click the mouse in the same spot and the same part of your screen 100 times in a row, it gets really obnoxious after a while. I would rather just eat the broken glass from the iMac I just punched than trying to keep using the mouse over and over and over again. It just drives me nuts. And who doesn't want to impress their old high school sweetheart with your amazing shell scripts? All the time. That's how I met my wife. Now, not everything we do needs to have a script behind it, but scripting is a way to speed up a common task, especially repetitive and simple common tasks. For example, changing ownership and permissions in the Finder, it's really sketchy at best. That interface just kind of sucks, frankly. Configuring the background image when a user logs in, which is something that's also not easily done with managed preferences. Sometimes we just want to have a script that just runs, that just takes care of it for us. Sometimes there are just things that we just don't have to keep doing manually. So scripting by itself really just refers to the process of writing programs that just generally does work for you. Scripts are usually designed to be run on demand. They're very portable, so they'll work in many different environments without a whole lot of changes. They're not compiled binaries like you'd get with a C program. There's lots of different ways to script, and I'm going to focus mostly as an introduction to Bash shell scripting in this session. There are things like Ruby, PHP for web scripting, Perl if you feel masochistic, Python if you actually feel like being cool and awesome and a real celebrity. Lots of different ways to go about scripting. You could even write a script in C++ if you really wanted to. It's up to you guys. It's your time. So scripting, despite being a lot less involved than writing a program for compilation, scripting still does have a lot of programming elements involved. There's control structures, variables, the ability to execute information based on logic, and there's environmental situations that you have to keep aware of. The nice thing about scripting, especially with something like Bash, is that you don't really have to do a whole lot of work. It's pretty much all taken care of for you. You just provide the logic, and the execution just happens. It's just magic. The shell is the very first thing you see when you open the terminal. The Bash shell is an acronym for born again shell. Okay, it kicks in, gives you a prompt, and waits for your instructions. There are many options other than Bash for shells, and if you use different flavors of Unix or Linux, you'll encounter different ones. T shell, C shell, K shell, all kinds of different ones. Mac OS X uses Bash by default, so we're going to go ahead and start with that. It makes sense for MacAdmins to have some familiarity with it because it's default. Why not? Shell scripting is a way to combine different instructions that you'd give into the shell into a single file and provide some kind of logic for executing them. The good news is it doesn't really require a lot to start. We're just going to go ahead and jump right on in. All right, so the first part of any Bash script is going to be the declaration of the interpreter, the # !bin/bash. That's always going to be the first line of every one of our Bash scripts. This declares to the world that this is in fact a Bash script and not a Python script or a Perl script. Echo is a basic command for echoing out data. It prints data out to the world. It prints out statements and does exactly what it sounds like. Read is how you would take input from standard input and put it into something like a variable. We'll definitely show examples of all this, so don't worry. The if structure we'll talk about more in detail as well, but this allows you to make conditionals. If condition A is true, then take some action. If condition A is not true, but condition B is true, do something else. If none of those conditions are true, do something different completely. There are loops in Bash, although some of them don't quite behave the way you'd expect if you're used to other programming languages like C or Java. And then finally, exit will be the last thing that will happen in a Bash script. And I'll go into more detail about all of these, of course. How do we get started? Well, the terminal is probably the first place to go. The first thing we're going to do is we're going to make a new file in our favorite text editor. And you don't actually need to write the script in the terminal. If you really want to, you can use any text editing program like Text Wrangler, TextMate. I do not recommend using TextEdit. I do not recommend using a word processor. Those are just asking for painful things to happen because they like to put lots of extra invisible formatting in there that will really mangle your scripts. Bash gets really, really unhappy when you start giving it invisible stuff. So, if you want to use a terminal, I prefer to use Pico as a text editor. It's simple. It's very easy. It's very intuitive. Typing in Pico into your Mac right now will give you an interface that tells you exactly what it is you can and can't do. Some people prefer to use VI. Some people will burst into flames when I say that VI is complicated, and they'll yell at me and judge me forever. You can use whatever you want, whatever floats your boat. Just whatever works, that's all that matters. So we're going to make a new script, all right? We're going to let's call it file.sh. The extension is not critical. Bash doesn't care if your script ends in .sh or if it ends in .doc or if it ends in .oh my god, what am I doing? You can call it whatever you want. The sh extension is really just for the finder's benefit so that you know in the future when you look at a file, you know that it's a script. When you double click on it, the finder doesn't try to open it in QuickTime because the finder really loves opening things in QuickTime when it doesn't know what they are. So first and foremost, with any Bash script, we need to declare the interpreter. All right, so our first script is going to say pound exclamation point bin bash. Then we're going to say hello world. We're going to echo out to the world that we love it. Just a hint at things to come in the future of your Bash scripting, the quotes you use here actually are important. Different kinds of things happen based on the kinds of quotes that you use. In this case, a double quotes is a simple string. I'm not going to go into too much detail about it now, but if you use backticks, which is the key where your tilde is, or if you use single quotes, different things can actually take place as a result of it. So do be aware when you use quotes to use the right ones. I really recommend reading tutorials on that particular aspect. And then once we've echoed out hello world, we'll just exit with 0. The reason we exit with 0 is to tell the shell that the script is done. 0 just means it ran successfully. Everything's fine. Everyone go back to your homes, nothing more to see. If you omit the value, all right, exit is going to return the status of the last command to run. In this particular case, if we just said exit without a number, it would take the value from echo and return that to the shell. Now in this case, as long as echo is able to successfully print hello world, it's going to consider a success. So in this particular case, whether we put exit 0 or exit, it's probably going to be a success. Now we can run the file. There's a couple different ways to invoke the file once we actually have it in place. You can just simply invoke it manually by using the shell sh file.sh, or you can use the / syntax. Now note that if you're following along and trying this right now, and you make a file and you hit / file.sh, it's going to complain. Can anyone tell me why? That's right. I have prizes for you guys. Come see me afterwards. All right, yeah, it has to have execute permission. In Bash, things aren't actually allowed to run unless they have the privilege of executing. Note that in the finder doesn't care, and the finder doesn't give you the option of setting the execute bit when you're looking at the ownership and permissions of a given file. We can only set read and write access. You can't set execute bit. You'll have to use a terminal for that. So the two different ways of invoking a script by using either the shell or the /, they actually do have distinctions. If you invoke a script explicitly by calling upon the shell then interprets the contents of the file and behaves accordingly. So for example, in this case, sh file.sh automatically assumes the file is a Bash script and will try to parse it as such. If it isn't a bash script, it'll be really confused and will complain at you. If you throw in a Perl script in here and you try to run it with bash, it'll just get upset. And we don't want that. We don't want to see it cry. When you have the / syntax, what it does instead is it uses the interpreter from the first line. This is why the first line is always important, the pound, exclamation point, bin bash, because it tells the shell what kind of script it actually is. So we could specify Perl in there instead, and it would run it as a Perl script. So / is the universal way of just executing a program. The link that I provided here, which you really can't see from this far away, that's really not very helpful, is it? In the future, when these slides are put up, and you can also come and see me afterwards, and I'll give you this link as well, there's a really good question and answer on this particular link that explains in very good detail the difference between doing it these two different ways. There's a couple different reasons for why we'd want to do it one way or the other, and they go into a great deal of length about why that might be and what cases you'd want to use one over the other. Questions on that? All right. So we've had a simple script that just echoed something to the world. So let's make it a little bit more interactive now. Let's ask the user for some input, all right? So let's add a prompt to our script and ask the user what their favorite app is. We'll read this into a variable. We'll do something simple, all right? So we ask the user, what's your favorite iOS app? And then we use the read instruction to apply it to a variable. Now, name, in this case, is a variable. I've put it in all caps just to make it easy to distinguish the variable from, say, another command. You don't have to use all caps if you don't want to. It's entirely up to you. And then we're going to echo the variable back with an acknowledgement. Now, you see, in this case, the variable is assigned through the read command. There are other ways to assign variables as well. We can assign a variable ourselves with the equal sign. It's very straightforward. You have the name of the variable, the equal sign, then the value, without any space in between. Now, because this is Unix, nothing's ever going to be as easy as it looks, so I do want to mention an important caveat that the equal sign is not just used for assigning value to variables. In some contexts, this can also be used to test equality between two values. So just be aware when you use this to use it properly. If you misuse it or if you have a typo or put a space in there, bash will go off in a completely different direction from what you expect and do something totally weird and crazy, and then you'll end up crying in the corner wishing it had worked. In bash scripting, variables have no type. Okay? Any variable can have any value in it, whether it's an integer, a floating point, a string, whatever. At any point, the value of a variable can change completely to something totally different from what it was before. So just be aware that you're not limited or locked to a type. If you're used to programming languages like C, which is very rigid and inflexible in its type declaration, it will tell you if you try to assign a variable incorrectly. Bash, it's a free-for-all. So when we want to use the value stored in a variable, as we saw earlier, you'll precede it with the $sign. The example here in the slide will show that if you try to echo out a variable with no $sign, it treats it as a word and echoes it out. So if you have a variable with a value of 10 and you just echo out variable by itself, you get the word variable, which is not what you want. If you echo $sign variable, that prints out the value stored inside that variable. And what do you think happens if you try to print out a variable that doesn't actually exist? It complains, right? It does do the right thing if you try to make up variables on the spot. It will tell you that you're just doing it horribly wrong. You should feel bad. Sure, yeah, you can. You could put quotes around pound variable. Oh yeah, absolutely. Yeah, so in this case, your favorite app is variable name, which means it's going to print out the value stored from the input we took in this previous script. Is that clear to everyone, how that works? All right. Now, let's move on a little bit to some actual logical structures, all right? Welcome to Programming 101. This is one of the basic things everyone learns in programming, which is the if statement. So the if statement checks a conditional. Then, and it's important that the then is included, it does something, whatever action you want. Do something can be say hello or say goodbye. And then if the first condition is not satisfied, you have the elif. People are going to yell at me no matter how I pronounce it, so I'm just going to pronounce it wrong my way. If you don't like it, it's too bad. If the first condition is not true, then it's going to test against whatever elif condition is next. And if that condition is true, it's going to do whatever's in the second instruction block. If the second condition is also not true, and none of the other elif conditions are true, it's going to do whatever's in the else. The else is just the catch-all. If it can't find anything to satisfy these conditions, take this action regardless. In an if statement, the elif and the else are optional. You don't have to have them. You can just have a simple, if this is true, do this test. You can have as many elifs as you want. You can go on forever testing different cases. If you really have a control structure that complicated where you have to have a dozen different tests, there are better ways of doing it than just using an if statement. Those can be looked up online. I recommend looking through resources to find those. Was it for me? All right, so on the topic of conditionals, a lot of the things that we're going to want to do, especially scripting for MacAdmins, is we're going to want to test files. We're going to see if certain files contain the data that we want or behave the way we want, or even if they exist at all. So the most important one, can't really see it very well, can you? Apologies for that. The most important one, of course, is the -e. Is that better? Is that easier to see? All right. Yeah, sorry about that. All right, so the -e simply tests if a file exists. That's all it is. Does the file exist at the location you specified? If that's true, then this returns true. All right, -f, if the file is an actual regular file and not a symlink or a device or a directory. -h tells you if it is a symlink. -s says if the file actually has a size greater than 0. Otherwise, if it's just an empty file, this will return false. Excuse me. And then R, W, and X tells you if the file is able to be read, written to, or executed by the user the script runs at. Now, when I say by the user, what I mean is when the script executes, it will execute with whatever privileges the current logged in console user has. If you run a script by using sudo, which if you went to my last session will be familiar, it will execute at root privileges. So just keep in mind, this applies to the current user. Here's some more that might be useful. Capital O, remember the capitalization is important in these. A capital O and a lowercase o will have completely different results and do completely different things. So when you're doing the options, make sure you get the right one. So the capital O tells you if the current user is the owner of the file. Capital G tells you if the group ID of the file matches the group ID of the current user. N, capital N, tells you if it was modified since the last time the file was read. And then newer than and older than tells you if it's older than if it's newer or older than a different file. So that requires two different files to compare. And then the most important one at the end is the negation, the exclamation point. Anybody who's done any kind of programming of any kind will be familiar with the exclamation point for the negation operator because it allows you to check the opposite of any given condition. So if you do a test to see if -e path to file and it says yes, it exists, you can also test if not -e file exists, if the file does not exist at this location. So it's sort of a way to do the opposite of whatever it was you wanted to do. Now in some cases there are operators already. For example, newer than and older than are automatically contradictory, so you don't necessarily have to, so a not older than and a not newer than can be in many ways, they can produce the same results. But the negation operator is a very powerful way to combine lots of different aspects of conditions and give you a lot more flexibility. So here's an example of a file test, all right? So if file 1 exists, then we do something to it. If file 1 does not exist, but file 2 exists and is newer than file 3, then we do something different. What happens if file 2 or file 3 does not exist? Who can tell me? Do you see an else? Nothing happens, right? It will take no actions. So this condition automatically assumes a couple things. If file 2 is newer than file 3, that's the only time in which the second action will be taken. If file 2 does not exist or file 3 does not exist, this condition will fail. Does that make sense to everyone? Everyone understands why that is? All right. And since we don't have an else here, there's nothing else that happens. It just keeps on going with the script after this. Loops. Loops are where things get fun in any programming class. Loops are also where everything that you thoroughly planned out, completely breaks down. For loops in Bash do not behave the way you might expect from other programming languages. The for loop takes an argument, and then it assigns this argument the value of each variable in a provided list. And I'll show you an example right here. If you provide a list of planets, then a for loop, as up here, this means that in each case, the variable planet will take on the value of one word from that list in order. So this will echo out the list of all the current planets. Does anyone understand how the structure of how this works? If you're used to a programming language like C, where you're used to a for loop that iterates between a certain number of values, it doesn't work that way. This just takes a list. There are, of course, while loops, and there's also the until loop. The while loop continues to execute the loop while a given condition is true. It'll keep on doing it until the condition stops being true. This does mean, of course, that you can have loops that run forever. So it's always a good idea to have some kind of base case in place so that your loops don't just go on forever and eat up all your memory. Until loops are sort of the opposite of while loops. Until a given condition evaluates as true, keep performing an operation. So for example, you could test to see if a variable x equals 10, and then as long as the x does not equal 10, you could keep adding 1 to x until you get 10. Does that make sense to everyone? All right. And then, as we sort of covered briefly, the last thing you want to do in your script is exit. You want to exit the script with the status of something to tell you whether the program went well or not. If you do not provide a value, it will use the last command. If you provide a value of 0, that tells the shell everything went glorious. You can all throw giant parties. You can invite all your friends. Everything's great. Any other exit value is considered an error condition. And you can use the error condition to test to see where it went wrong. Generally speaking, as MacAdmins, in most cases, we're not really going to be writing scripts that are going to require that much complicated debugging. If the script runs, then that's usually what we want. If the script doesn't run, that in itself usually tells us enough about why our script failed. If your script really is complicated enough that it has an exit value, good for you. If your scripting is going right, you generally don't need to worry too much about the exit value. But it is a way to use Bash programs to sort of, they'll often tell you an error code if they fail for whatever reason. And this was particularly applicable if you use any Mac OS X specific commands. They all tend to have long lists of error codes that they'll give you in case something went wrong in the process. And that's also a very helpful way to look up online what might have gone wrong in your execution. But for our particular purposes, we mostly just care about exit 0. Yeah?
Your exit codes, that doesn't catch anything, though, that, say you submit and the script assumes that it went correct, even though it didn't get no value, maybe the code actually didn't execute correctly.
Yeah, well, so whenever it encounters an exit command, it interrupts the control flow. So for example, you could exit out of a loop to exit early if you wish to. And if you exit 0 out of a loop, it makes no difference as opposed to exiting 5 out of a loop if you don't try to actually catch the error code. An error code is only useful if you actually test for it. There's no point trying to catch a condition you can't handle. So if it's at the very end of your script, it's really only relevant to you as the person who's running or testing the script whether or not it executes successfully. Because if it didn't execute successfully, Bash will usually tell you why. It'll usually tell you what part of your script failed before it even got to exit. In most cases, when we're writing scripts, especially in the beginning, we're not going to be exiting out early from the script unless we specifically have a failure condition that occurs somewhere in the script. Does that make sense? Is that kind of?
No.
Okay, good. Does everyone understand what I was saying there? About why, we're not going to exit out of a script early in most cases unless the command actually fails to execute. If we give a command and Bash says, oh, I don't know what's going on here, usually it's because there's a syntax error or something like that. Bash will usually tell us why it failed. So in many cases, our exit code is kind of irrelevant. But it's a good habit when you're making Bash scripts to be gentle and give it a 0 when everything goes right.
Now, maybe I'm coming at this from a different point of view. Talking about checking if a file is there. Say we want to do a bunch of operations, the file's not present or configured. I assume that you could have a situation where an exit would happen very quickly if you do the verification and find what you want in order.
Well, think about it this way, right? If you have a control structure, if you have an if statement inside your script that tests to see if a file exists, presumably you're going to do something based on the results of that condition. I mean, in which case you wouldn't exit the script because you would just handle it right there.
Right, but I mean, if the question is file through there? And if it's not, then I do a bunch of stuff.
Yeah.
Then,
Otherwise, I mean, in an if statement, if it fails, it'll just keep on going in the script. So you could exit afterwards and say, all right, if I got to this part of the script, that means then it didn't do whatever I want it to do. There's different ways to handle that. But you can handle that in the script logic itself. You can already account for that with an elif or an else statement. So generally, exiting is not a good way to determine your program's flow. Exiting means that the program interrupted abnormally or did not go the way you expected it to, and usually for a reason that it's beyond your control. The idea behind a good script is that you can kind of test for all the permutations of the values that you're checking. Does that make sense? All right. I do want to talk briefly about piping. This is one of the most important features of Bash, a very wonderful feature. Piping, which is simply the pipe, which is the key right above the enter key on your keyboard, it takes the output from command A and uses it as input for command B. So literally just an arrow sign. Command A goes into command B. This example here looks a little bizarre if you're not used to Bash, I know. This is a way to search through the list of open files for something. Okay? LSOF lists all open files. So it's a good way to see, okay, you're trying to eject a disk. The disk says, oh, sorry, I'm still in use. Like, okay, what is the holdup here? What's holding on to this? Do an LSOF to look at all the open files. Now, normally that would just give you a list of all open files. Now, in Mac OS X, on any OS, there's a lot of open files at the same time. And we don't want to have to sit there and sort through every single one of them. So we can use a command like grep. Grep is a wonderful command. Grep just searches any kind of output for a given string. So in this case, let's say we're ejecting a disk called Nick. And it says, oh, sorry, Nick's busy, can't eject. So we'd want to say, okay, what's going on here? LSOF, pipe, grep, Nick. That will tell me the list of all open files that have the phrase Nick somewhere in it. Whether it's, /volume/Nick or there's an actual file connect, whatever. It's a good way to search through data to narrow down the results that you're looking for. So that way we don't have to sit there and look at the entire output of every command ever. Does that make sense to everyone? How useful the grep command is? Grep is most often going to be used after a pipe because in most cases we want to give it a subset of information to search through. So we'll take the output of any given command, pipe it into grep, and there we go. Yeah, you could do a complete directory listing on your local disk and then pipe the output into grep and search it that way. That will return everything on your local disk that you search for. That's a really slow way of doing it. It absolutely can be done. It's absolutely possible. Generally speaking, people have made better search systems because that particular, search straight from the top to the bottom is a very slow algorithm. There are much better searching and sorting algorithms out there. And that's why Spotlight was invented, basically, is to avoid having to do things like that. But that's absolutely one permutation of the use of grep. You take any possible output you want, pipe it into grep, search for any kind of string or regular expression or anything, and you'll get only the results that apply from the grep search. And you can also do a reverse grep search. If you do a grep-v, it'll give you everything that does not match the search pattern. All right, now we're going to tempt the evil spirits of the demo world, and I'm going to show some examples. This is all going to go horribly wrong. It's going to be hilarious. Oh, that's the first problem. All right. Can I make this bigger? Let's see if I can make this bigger so people can actually see. Bigger. Oh, good gravy. Good enough. Can people see this? Is this readable? All right. So let's do a very basic script that I've already made. All right. This script, it's like riding a bicycle made of dreams into friendship. This, we're just going to echo out simple things. We're going to tell the user, we're going to make a file, and then we're going to change permissions. So we're going to go ahead and create this file by using the touch command. Touch does something simple. If a file exists, it updates the modification date. If the file does not exist, it just makes one. It's just a blank, empty file. So we're just going to touch this file called testfile.txt. And then we're going to tell the user, great, everything worked. We made this file. Then we're going to change permissions on it. All right? Change mod, does that sound familiar to people? People know what I'm talking about when I say change mod? Anyone's head exploding? All right, good. And so we're going to give it read-write permissions for the owner and read-only for everybody else. And then that's all we need. And we're going to exit. Now, we have exit with no value here. So what's the exit going to be? It's going to be the result of the change mod operation. Now, the only way, now what do you think the change mod operation is going to say? Well, it's going to say everything's fine. Unless the file does not exist, and we're trying to change mod a file that doesn't exist, which means the first statement, the touch statement didn't work. In most cases, we're just going to get a return value of 0, which means everything went fine.
The exit wouldn't be the result of the echo versus?
Oh, I'm sorry. I can't read. This is really hard for me when I can't read. Yeah, no, it's going to be the echo, which unless your terminal explodes, is pretty much going to be 0. Unless for some reason it can't output, it's just going to be fine. So let's go ahead and I'm going to move this over so you can actually see the file get created. Okay, so we've got this script in place. Let's just go ahead and run it. Wah, 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 wah. Yeah, that didn't go so well. Can anyone tell me why? There's no execute privileges on this script. I have to turn around and look at this. Derp. It's difficult when I have to, work backwards. Now we're on the trolley. All right, let's try this again, this time without the failing. Oh, glorious. I feel happy already. All right, so it did exactly what we told it to do. It made a file, and it now gives it the right privileges. And here it is. We made our file. And if we look through the command line, it has read and write privileges for me and read only for everybody else. Glorious, right? All right, so that was nice and easy. So now let's take a look at one that involves user input. I'm going to make this easier on myself and turn mirroring back on. I hate turning around. Oh, goodness, the resolution. Ah, it burns. Good enough. All right, we'll just go with that. Okay, so here we've got one that actually takes some input. All right, so just like we had before, we're going to ask the user, well, they don't want to name the file this time, and then we're going to make a file based on their input, and then we're going to do the same thing. This all looks good, right? So we all covered this earlier. Everything should go completely fine without any problems whatsoever. Otherwise, I'll have to sit in the corner and cry for a while. All right, so now we have input. What do you notice about this? There's no prompt. It's just blank space. It's just going to ask me. It's going to sit here waiting for my input until I give it something. If you're used to the command line, you're used to prompts that say, all right, enter data now. Nope, it's just a blank space. All right, what are we going to name this file? Come on, someone give me something. What? Boring. I like your style. All right, so now we've got this file. There it is. Oh, look, glorious. We've got a file called Snickers. Now, because we didn't give it an extension, the Finder has no idea what to do with it because Finder, what can we do? There it is, Snickers with read write for us, or me, and then read for everybody else. Everything went great. Okay? Now, what if we did this script again, this exact same way? What do you think is going to happen? It's going to touch, which means it's just going to update the modification date.
Right.
Now, what if, in this case, instead of touch, derp, H, there we go. So let's say instead of touch, we're going to, what this is going to do instead is this is going to put the word hello as the entire contents of that file. We're going to take whatever's in that file and overwrite it with the word hello. Okay? Now, before we do that, let's look at this file, Snickers. Okay? And let's write hello Nick in there instead. So if you look at the contents of this file, it says hello Nick. What's going to happen now if I run the test user script?
It's just gonna override hello in it.
Yep, that content is gone. Now, for the scripting purpose, for demonstration purposes, this is totally fine. But what if this is actually a really important file? What if we don't want our script to just overwrite whatever the contents of that file are? What if we want to, take a little bit more care to make sure that we're actually working on a new file, not a file that already exists? Well, let's do a little bit of error checking. Okay? So what we're going to do now is we're going to ask the user for a name, test to see if that name already exists. And then we're going to go ahead and create the file. Now, there's a lot of problems with this script. Everything about this script is just bad. Who can tell me why? What happens if the file name exists?
Essentially fails with a nice prompt.
Because if the file name exists, it's going to say, all right, enter another one.
Or it doesn't.
What happens if I enter that same name the second time? It's going to do nothing. Nothing's going to happen. It's going to read the file name, look for my input, and then the program is going to be done. It's not going to do anything with my input. So this script tests for a situation and then doesn't care. So this is a bad script, right? We should all feel bad just by looking at this. I feel dirty. I need a shower now, all right? And then if the file name does not already exist, then we do the right thing. But we don't have any way to get all this up there. We're just not even doing it right. So this script just makes me sad. Instead, what we're going to do is we're going to fix this. How should we fix this? What would be a better way of looking at this condition? What would be a better way of making sure the user does not provide a name that already exists? A loop. What kind of loop? A while loop. Oh, glorious. You guys are so smart. I want my kids to be like you. All right, so a while loop. We could say, all right, as long as this file name exists, we're going to keep asking the user to do a better job. The user provided us terrible input, and we're going to punish them. Here we go. So now we look for input. As long as this file name exists, we're going to keep going back and saying, no, give me something better. Nope, it still exists. Do it better this time. Keep on going. And it's going to keep doing this until the user finally satisfies the requirement and gives it a file name that's not already in existence. And then what's going to be even worse is it's going to talk and freak everybody out. So if I give it a name that already exists, no, denied. That's great. We don't want to overwrite the file that we have. We just want to work with something new. So I'll give it something new. How about Milky Way?
Okay, now we've created Milky Way. Don't touch it again.
There you go. So that was done with the say command, which you can actually make, have the computer talk to people. I really don't recommend in practice incorporating the say command into all of your bash scripts. It's going to make your users really confused and probably a little unhappy, and after a while it stops being funny and starts just being kind of sad. But you can do whatever you want with your users. I refuse to take any blame for it. It's your own fault.
It's not a bad quick debugger.
No, absolutely not. It's yeah.
It says something, it works.
All right, so that pretty much covers bash in a nutshell. That's sort of the introduction to bash shell scripting. Now, as I said before, there are a lot of different ways to have shell scripting. There's a lot of different ways to have scripting in general. The shell is not the only way to make cool things happen. There's Perl, there's PHP, Python, Ruby, whatever. And many of them are invoked very similarly. You would call the script with a different interpreter. So, for example, if I wanted to have a Perl script, then I would have !! user bin, or user bin Perl, and then I could invoke it manually by saying user bin Perl, Perl script -pl. If you're still learning Perl in this day and age, God help you. All right, AppleScript is another great way of getting things done because AppleScript's built right into Mac OS X. Yes, well, Apple, they'll take things that we love away, and they'll give us terrible things in return. AppleScript can be, oh, sorry, go ahead.
On the previous example, running that script, if you were to run it on somebody else's, opens the terminal and the actions.
That's correct. Yes. If you take that file.sh into the Finder and just double-click it, it opens it up in the terminal and then tries to execute it, assuming it has execute privileges set. If it does not have execute privileges set, the Finder will probably try to open it in the terminal, and then it will fail, or it will try to open it in the text editor, neither of which will really accomplish what you want. So it's always a good idea to make sure when you're moving scripts around, make sure you're giving them the right permissions. All right. AppleScript can be accessed very easily from the AppleScript editor from the utilities folder. And AppleScript is really easy to learn. It's very readable. It's a mostly English scripting language. And everybody has access to it in Mac OS X. The script editor application itself is very good about providing you with a syntax checker. So it will, before it runs your code, will tell you if you're doing something horribly wrong. And it has also, I'll get to the other features in a moment. It does have the ability as well to invoke shell scripts. You can run a shell script from AppleScript. So you can sort of combine the best of both worlds. You can have a shell script that runs an AppleScript, that runs a shell script, that runs Automator, that then proceeds to make your head explode. But you have the options. They're there. It's glorious. Automator, as I mentioned briefly, is another wonderful thing. And I forgot the .app. I should feel terrible. Automator is in your applications folder. It's new as of 10.6, so it's not really new anymore. But it provides a very easy visual interface for doing a lot of the similar tasks that we'd want to do in scripting. So you can ask the user to select a file, take that file, pipe it into some other program, run an AppleScript on it, run a shell script on it. It's a way to combine sort of all these worlds together. It's not really a language per se, because it's just a simple visual point and click. This command, then this command, then this command, et cetera. But it's a good way to accomplish a lot of repetitive batch processes with almost no effort. Together, Automator and AppleScript can let you do some pretty cool magic.
And it also puts a graphical front end, like you're talking about.
That's right. You can actually provide an interface to the Automator action itself that tells the user that you're actually doing something, rather than just a whole bunch of text that would freak them out and make them want to hide in the corner.
Or pull open a terminal window that would confuse them because they've never seen it.
Exactly. So if you have to spread things around to users, Automator and AppleScript let you do things with the interface. Your bash scripts will all require terminal access and all require the terminal to run. So if your users will, start crying and, start hurting at the sight of the terminal opening up and doing terrible things, might want to avoid that. Yes?
Can you make a bash script just run completely in the background without popping up the terminal window?
Well, yes. Yes, you can. There are different ways to do that. If you just run a script, for example, if you SSH into a machine and just run a script, the user will never see anything unless it produces output. Even if it produces output, if you're running it through SSH, you'll get the output, not the user. The user will only see it if they double-click on the script, the SH file, in the Finder. That's the only case in which they would actually see the terminal window open. In most cases, as MacAdmins, we don't want the user to see this kind of crap because it just confuses them, and then they start calling, and then it just goes ugly from there. So a lot of the tools that MacAdmins will have access to, like SSH, Apple Remote Desktop, Radmind, whatever favorite tool you want, they'll just go ahead and run these things without ever telling the user that it happens at all. And this is also important because this means you can also run commands on computers that aren't necessarily logged in, which is important. In a lot of cases, you just want to turn the computers on, do stuff to them, and then turn them back off without having to worry about someone coming along, typing in a name and password, et cetera.
Also, like launch D, you can put stuff in the launch D or login hooks.
I'll get to that. All right. So the AppleScript, the editor, also has a really neat feature, which is the ability to look at the AppleScript dictionaries of other programs. Apple provides a lot of good scripting elements for most of its programs. Not all developers do, like Adobe. Most of the Apple dictionaries are also available online, but what it means to open up a dictionary means that you can look and see a list of all the possible things that you can do through AppleScript. And you can, again, because you can use AppleScript and shell scripts together, you can find ways to incorporate simple Apple scripts into your bash scripts already. So you can really combine all of your workflows into one great, wonderful source. If you turn on full keyboard access, especially, AppleScript becomes a really, really awesome way to interact with the GUI itself. AppleScript has a feature that almost no other scripting language does, which is you can press buttons. You can input stuff into dialog boxes. I don't necessarily recommend relying on AppleScript's ability to play with the GUI as your primary means of getting around an interface. If you have to do that much work in the interface, you might want to consider looking to see if you can alternatively do it without using the GUI at all, because the interface, again, is slow and complicated and annoying. But if you really have to use the GUI, AppleScript is the best way to go about it.
Is that XY based or is that element based? Like
Element based. So you can tell AppleScript, okay, look at the front program. If there's a button, click it.
So it's not like just click the button at
So if you turn on full keyboard access, if you've ever tried turning that on your Mac, and you actually have the ability to migrate a little highlight box over every single GUI element that's interactable, AppleScript basically has that ability as well.
Okay, so if you go to a machine that has a different resolution or something, you're not gonna.
No, it's not. Yeah, it's not. It's they're scalable assets.
Okay.
So it's based on the list of elements that you could interact with. Now, like I said, though, that's a terrible way to do it. And if you have to come to that, I feel bad for the software you have to work with that requires you to script a button press. But there are developers out there who cannot create installers for the life of them and make us press buttons to run things, especially in the educational world. I run into a lot of software that just, ugh. All right, so sometimes we want a script to run at a specific time. Sometimes we want it to run repeatedly. We want to schedule things to happen, and we don't want to have to we don't have to do it manually every single time. This is where LaunchD comes into play. Before 10.5, we had cron, which was a nice, easy way to add something to an immediate schedule. It was a one-liner you could use to say, all right, run this program at 8 o'clock on Wednesday. We don't have cron anymore. It's gone. Instead, we have LaunchD. Now, LaunchD, starting at 10.5 and beyond, took all the old initialization processes and replaced them with XML plists. LaunchD is a huge can of worms by itself. I'm not going to go into too much detail about it because there are other sessions that talk about it. And if you want to know more about how macOS 10 handles events and scheduled occurrences and things like that, I really recommend attending one of those sessions. There's also a lot of documentation online about LaunchD, how it works, and how to use it. But it's more complicated than cron in that you can't simply use one line to schedule an item in LaunchD, but it provides you a huge amount of flexibility for conditions. When a disk is inserted, run this command. Run this command if a certain user logs in, et cetera, et cetera. You can create an XML plist that contains information about your launch parameters. For example, what program is being invoked, the time or the date, the conditions for when it would run. And then this plist, you would then store it in the /library/launch agents or launch daemons folder, either for the user or for the system, depending on who you want it to run as. LaunchD, it's big, it's complex, it's arguably very beautiful. Do the reading. It's totally worth learning about how macOS 10 handles it.
Lingon?
Yes, there is a program called Lingon, which you can find on the App Store right now, which is not very good. The App Store version totally got rid of all the things I loved about the old version. You can still find the old version kind of floating around the internet if you search for it, Lingon 2.0, or is it 1.0, whatever it is. The current version on the App Store is a paid app. It used to be open source and free, and then he made it a paid app, which made everybody really, really upset. You all know how that goes. But it is a way to add things to LaunchD without having to sort of dive into the command line access of it, because like I said, it is kind of complex, and you need to do a little bit of research before you get into it. The best advice I can give for any scripting, programming, or any kind of development is just try it out. All right? If you're worried about mucking something up on your own workstation, make a VM. Find someone else's workstation. Find some user who wants to give you their computer for 20 minutes. Hey, can I borrow that? I need to run this deletion script that might delete your whole user library. Sorry about that. I'm a hands-on learner myself, so I really do learn better by trying something out, seeing it fail, playing with it until I can figure out all the different ways that it's going to flow. Whatever your learning style is, whether it's visual, auditory, whatever, I really recommend the best way to learn is just to get your hands dirty. See what works, see what doesn't work. I encourage you all to try. And for the most part, unless you start messing around with the system stuff like sudo rm-rf star, you're generally not going to mess things up too much. Too much. That's your own problem if you delete your own hard drive. I'm not taking responsibility as your scripting introductor. Here are some resources, some links. These slides, I'll make these slides available if anybody wants them. Follow me on Twitter and I'll put them up as people have requested it. But this first link right here, the Bash scripting guide, this is probably the most comprehensive, wonderful source on the internet for learning about Bash. It's got everything, and I mean everything. There's all kinds of stuff that I even have no idea what the hell's going on there. It's just bizarre. But you can find all kinds of tutorials online just by doing a simple Google search. Throw a rock at Google, pick one that looks good, and go with it. These AFP 548 and the dev daily links, these go into more detail about LaunchD and how to use it and how to incorporate it into scripts. I really do recommend both of them as good starting points for LaunchD. And of course, Mac Enterprise. If you're not already on the Mac Enterprise mailing list, I really recommend it. There's a lot of great people there, including myself. There's a lot of really smart people who can answer all kinds of questions about pretty much anything Mac related. And I really recommend you get on there and just talk to everybody and just see what kind of information you can get there. It's a great fountain of knowledge. That's about it. Thanks, guys. Thanks for coming. And anybody has any questions, I'm here. What's up?
You mentioned how you work in a whole couple, I guess, student labs and stuff. Can you give me maybe an example or two that you use scripting to, as far as deploying?
So one particular example that comes up a lot is that Apple provides no real easy way to prevent the user from changing the background image, right? It's annoying, but any user can change the background image. We can't really stop them effectively. One of the best ways to do it is to have a script that runs on login that sets the background image ahead of time. That's one way of doing it. If you do any kind of image-based deployment, most people will have a first boot script that just sets a whole bunch of parameters ahead of time. For example, if you use Apple Remote Desktop, you want to kickstart the Apple Remote Desktop client with your settings. You want to turn off FireWire networking because you're probably never going to use TCP over FireWire because why? You want to set your airport ahead of time to connect to a specific SSID with a specific password, things like that. That can all be scripted well in advance. So you'd have a script that runs on startup or a script that runs the very first time you image a machine that takes care of these settings for you. If you do any kind of MCX, managed preferences, scripting becomes a huge benefit here because it allows you to control the different aspects of the system that you really want to manage and put it all into one easy package. If anybody here is familiar with Monkey or InstaDMG, both of those make great use of scripts, and both of those allow you to really customize a lot of the way you deploy things. There are other sessions on that, so totally recommend them. Alistair is giving a great session on InstaDMG imaging.
Can I piggyback on this?
Absolutely.
I mentioned before, OS 10 has something called a login hook and a logout hook.
Yeah.
Which basically is a script that runs at login or logout.
There is one important caveat to login and logout hooks, though, okay? Any vendor, and I mean anybody, can set a login or logout hook. You can only have one. You can only have one login hook and one logout hook. So that means if you rely on a login hook and you install a program that happens to come along and replace it, right, anything you had in there is gone. There is no way to prevent this from happening. So login hooks, sure, they do work. I don't recommend them I don't recommend relying on them for a script that you want to run on a regular basis of a user logging in. There are other ways to do it that I think with LaunchD that are preferable. I mean, worst comes to worst, throw it in a user startup items. That's the simplest way. It doesn't mean the user will see it, but it also means that at least it'll run. But login and logout hooks, it's just too easy for all that to go away. I actually have encountered a situation in which software overwrites the login hook. And it's frustrating beyond belief when all your hard work goes away and you have no idea why until you look at the logs.
Also, this is for MCX.
MCX, yeah.
You can institute a login script.
Yeah, absolutely. There are different ways to do that. Yeah, MCX is a good way of doing that. I mean, if you're not familiar with the term MCX, if you've ever used Workgroup Manager from a Snow Leopard server, or any of the previous server programs to, it's a way to institute managed preferences, as in you control a specific preference file, a plist somewhere, and you make sure that a specific key always has a certain value. So for example, you could set it so that, well, that's a good example. Yeah, doc items. Turn on Safari debug menu. Turn off Safari debug menu. Things like that. Anything that you can find in a plist file, you can script through. You can control through MCX. Now, MCX may not necessarily exist in Mountain Lion when it comes out. So there are sessions on both on MCX and on Profile Manager, which is sort of the new managed preference system. That's in Lion and it's going to be more in 10.8. So if you want to know more about those, I recommend attending those. Any other questions? Yeah.
I know Mac Enterprise has a spot for sharing information. Where do you recommend if people here have great scripts that are sitting around, that is a good spot repository for sharing those handy little tidbits that we come up use every day?
I would totally recommend. Oh goodness, resolution. Sorry, hold on a second. I can't see. All right. osxdeployment.com is a fantastic resource for this, if it ever loads. There we go. It's a wiki. All you got to do is sign up, and Nate Walk, who is here somewhere at this conference, he just has to approve you, but it is a fantastic repository for people who just share stuff about all the things that they've tested out with Macs and how they got them fixed. There's scripts, there are guides, there's how-tos, everything you can imagine about OS X deployment and management, it's here. I'd also like to recommend AFP 548. Is also a great resource for a collection of useful Mac tools, and by tools I mean scripts, guides, how-tos, etc. There's a lot of really useful information about just everything Mac-related. So both of these places, I'd say, are great starting points for just finding stuff that you might want to know. Because like I said in the last session, for any of you who are attending, in many cases, someone else has already solved your problem. All right. In many cases, someone else has already figured out how to deal with the problem that you're encountering. There's no reason to reinvent the wheel. In many cases, someone has already posted a solution online somewhere. So, but when you run into a problem, before you try to tackle it by scripting it all out, see if somebody else already has. Don't waste your time. Waste someone else's time. That's what they're there for.
Or use it as a basis.
Right. Or copy and paste and then pretend it's yours and then feel smart when your users are amazed.
I guess talk about sharing scripts. Could you speak a little bit to comments?
Well, yeah. I didn't really talk about commenting very much at all. Very much at all. But comments, as you could actually see, these little. No, I don't have any in this one. This is a terrible example. Ugh, I should feel bad. Here we go. Oh God. Why reinvent the wheel? There we go. All right. So here's an example. All right. A comment is anything except for the interpreter that starts with a pound sign. This means don't try to do whatever I wrote here. This is just for the purpose of human readability. When you're making scripts, especially if you're making complicated bash scripts that you're just going to set once and forget it, it's a good idea to document what it was you did, why you did it, and how you did it, because that means 10 years from now, when you look at it, you're going to say, what the hell was I thinking? Right? We want to avoid that. Or you retire, or you get a new job, and the guy before you wrote all these scripts for doing everything and didn't document a single one, and you're now the proud owner of 100 lines of spaghetti logic. Yeah, that's bad. We don't want to do that. So when you're doing things, especially if you're testing things out initially, put comments in. Be a good sport. Be a good soldier. Put comments in. Share your script with somebody else. It'll hopefully answer all their questions. And if not, that's what email's for.
And also putting a comment in is good for debugging because you can take a piece of logic out.
Yeah. If you want to, for example, all right, I don't want to echo this out anymore. Now it's a comment. It won't be executed. Any questions on that? Any more questions at all? Yes.
Where do you recommend that let's say we've got a bunch of shell scripts, or bash scripts, where do you recommend they be stored on a user's machine? User local?
Well, that depends on how much you want the user to be able to interact with them. Generally speaking, if you want a script to run, you want to put it somewhere in the path. I talked about this in the last session. I didn't talk about it in this session. The path is just a list of locations that scripts that it will search for when trying to run a script. In many cases, user local is a good place to throw things where the actual logged in user won't find them, because most people don't go poking around the invisible USR directory. If they do, oh boy, that sucks for you. But if you want a script to run, only as root, for example, and you want to make sure that it's like a login script or something like that you don't want the users to ever see, put it into private, put it into the root's home directory. That space is always there. It's always hidden from every other user except for root, so it's a safe spot. If it's a generic user script, you can throw it anywhere. You can make it invisible if you simply put a dot in front of the name. The users won't be able to see it in the Finder unless they turn on hidden files, but in most cases, users generally won't do that. So I would recommend, if you're writing something and you just want to have something simple, user local is a good spot. Yeah. You can follow me on Twitter. I'll post both these this and the last session slides up in PDF form, and I'll post it on Twitter because people have requested it repeatedly. Yes.
I have two questions. First goes back to your comment earlier. Why do you care what the desktop image is?
Well, in a school situation, the kids will change it repeatedly, and if they can change it to anything they want, including an image from the internet, if you have a lab computer that stays there all day and a kid changes the background image to something, and then another class comes along, like a kindergartner comes along and sees it, like, ooh, look at this picture, and then all of a sudden all the kids gather around, it's just a disruption.
But it's by the user. Do you not have Active Directory or something like that?
Well, okay, yeah. In our case, in the particular lab situation I'm thinking of, we don't have directory services in that lab. It's just a single login. But it was one example. It's.
You got a computer with a 20-inch screen, and you press up something inappropriate in the middle of class.
Or if your computer is being shared to the projector.
Right, but a login is not Active.
No, it's true. It's true. It is one example. It probably won't come up a whole lot if you're using directory services, so that won't matter as much. But we have laptop carts that are not based on directory services. They're just mobile laptop carts that just user logs in with a generic login. That's a case in which I probably won't see the laptop for a month because it'll just keep going from user to user. And it just, then someone's going to email me and say, hey, this picture has a bunch of cats and all the kids keep looking at it and not focusing on their work. Like, this isn't really a technology problem. Why are you emailing me? Like, come on.
And on that note, I noticed, I think it was when we did the snow letter update, that it kept defaulting to internal speaker on a Mac Pro. And I looked everywhere for a way to default to the speaker output on the back and have desktop speakers.
You have found one of the few things that nobody knows how to manage. The built-in audio setting is, I swear to God, it's invisible. It's no one can figure out where that plist is stored. There's a guide on the Mac Enterprise mailing list that someone wrote about their attempts to figure it out, and they found one of them.
Isn't that EFI?
What?
Isn't that somewhere in VidArch?
I think it might have been. Yeah. But
The script setting at VidArch.
yeah. So you have to have a script. You have to have an EFI script that changes your audio.
There was a
Fantastic.
There's a little executable you can download.
Yes, someone made one that you can download that changes it
Right.
for the next
If you
boot
start
up.
Like in your scripts directory, and then you could write a script around it to change. That's how we fixed it.
Yeah. It's
I'm the poster, and that's how I fixed it.
oh, there you go. Yeah. So it's that's one of the ugly ones. Not everything is easy to access, unfortunately, because Apple. Right, because Apple. But in a lot of cases, there are a lot of things that are easy to find. If you want to change the way the Finder looks, the icons that show up on the desktop, that's stored in the Finder plist. The sidebar of the window, when you open up a window, this sidebar here, all these settings, this is all in a plist, the COM Apple sidebar list plist file. Yeah, and this one's easy to manage. So this might be something you want to manage through MCX. You could say so that, okay, all users will not have a list of all nearby computers show up, because in most cases we don't want the users to have a list of all nearby computers show up. So we'll just turn that feature off for everybody through MCX. That would be an example of something you might want to script. Or if you don't want to use MCX, you just have a script that runs on login that does it.
Another reason to use a custom desktop is you can use that to convey information.
Yep, here's a link to the school website. If you want to access your file share, click on this icon, things like that. Possibilities. So I hope you guys got something useful out of this. Oh, sorry, go ahead.
That's just a question. If we run into problems with
the projecting like marks to the projectors sometimes.
Mhm.
Different marks. Is there a way of scripting that? Or?
When it comes to things like physical screen resolution, okay, that's called a by-host preference, which means that, so there are preferences that are specific to the system, preferences specific to the user, and there are preferences that are specific to the system, to the host, because you don't want to share things like resolution across multiple computers, because that's unique to an individual computer. So that's a by-host setting, and that's a little bit more complicated to actually work with because it's in a separate place. That shows up in, oh god, the library is invisible. That shows up here in the by-host settings. And as you can see, there's a whole bunch of different settings here that apply only to the host, as in only to this computer specifically. You can set MCX. As of 10.5 and 10.6, Workgroup Manager will respect by-host preferences and will specifically import by-host settings and do the right thing when you deploy them. But it's going to take a little bit of digging to find out the ones that you want. So just be aware, it's not quite as easy as managing something like the doc plist. Like this is an easy one because there's only one doc plist and it's easy to change. So the by-host settings require the UDID of the device. Anyone else? Thanks for coming, guys. I hope you guys got a lot out of it. Enjoy the rest of the sessions.